Hi, I'm television meteorologist Mike Fairborn. It's my business to be concerned about the weather and its effects. One important effect of the weather is the deterioration of asphalt or blacktop pavement. We all need to be concerned about the deterioration of asphalt pavements because we depend on them for safe transportation and because so many of our tax dollars go into maintaining Minnesota's asphalt pavements. Oxidation by sunlight, surface wear by traffic, and water infiltration are major causes of pavement deterioration. One of the most cost-effective maintenance methods for counteracting pavement deterioration is seal coating. So I want to go over with you what I've learned about seal coating from the experts, Minnesota's public engineers and pavement maintenance professionals. They've provided me with some solid research data, but they also stress that it takes skill to put down a good seal coat, skill that comes from experience. Later, I'll cover the basics of planning a seal coating operation and give you some tips on how to do the job right. But first, I want to explain the purpose of seal coating. A seal coat works to protect a pavement just like paint protects your house. Paint doesn't add any strength to a house, but it keeps the sun and water away from the structure so strength is maintained. Seal coating does the same thing for asphalt pavement. There are 4 main types of seal coats used in Minnesota. This one is called fog seal. In a fog seal, dilute liquid asphalt is sprayed over the pavement to create a thin protective layer. This is a slurry seal. It's a mixture of aggregate, what many people call gravel, and asphalt. It's pressed into a very thin layer with a special squeegee. Next, there's the sand seal. It's composed of 2 layers. First, liquid asphalt, and then a thin layer of sand is laid down and rolled into the asphalt. Last is the chip seal. Because chip sealing is the most common type of seal coating done in Minnesota, I'm going to concentrate on it here. Like a sand seal, a chip seal is composed of 2 layers. First, liquid asphalt, then a layer of aggregate. A chip seal protects the pavement like all seal coats, but it also offers an added benefit. The aggregate replaces the road's original skid-resistant surface that becomes worn down after several years of use. Now, you only get these benefits of a chip seal if you do it right, and you can't do it right unless you plan the operation carefully. The first step in planning is to decide which pavement condition ratings gathered in the field. Seal coating is called for on pavements like this that have already begun to wear, crack, and dry out. But a pavement that has deteriorated this far will not benefit from seal coating. It needs more intensive maintenance, such as an overlay or reconstruction. Once it's been decided to seal coat a certain section of pavement, the next step is to select the right materials. As we've seen, the 2 components of a chip seal are liquid asphalt and aggregate. In choosing the right types and amounts of both materials, it's important to apply an engineering design process. Because there's a limited choice of aggregate types available in each particular place, you usually have to choose your aggregate first and design around it. When choosing an aggregate, size is one important consideration. These are the standardized sizes of seal coating aggregates, and this is the most commonly used. The FA stands for fine aggregate, and the 3 designates the size range. Most pieces of FA3 are about 1/4 inch across. The shape of the aggregate is also important. We've had this sample made up during a typical seal coating operation to show why angular shaped aggregate is best. It's chip seal laid on a piece of plywood. If you look closely, you can see how the angularity of the pieces allows them to interlock so they can't easily be dislodged. Also, it's the angles that make for a skid-resistant surface. But cost is also important. To get the more angular pieces of aggregate, the rock has to be crushed, and that's more expensive. Sometimes you choose a less expensive and not so angular aggregate like this. No matter what kind of aggregate is used, it has to be clean, like these